following up on question 9, we have question 10. Now, question 10 is giving us a table. Note that it's telling us that these values in the table are for a continuous function, right? So we have a continuous function g where this is just some selected values from that function. And the question is saying, what is the fewest number of times where your height of the function g of x could equal 45 on the interval 0 to 30? So how many times are we going to be able to see that the height equals 45 on the table, right? So from 0 to 30, like somewhere in between the table. Well, hopefully, just as we talked about with number 9, number 10 is asking us to use the intermediate value theorem, right? The only theorem we have that can verify whether a height is supposed to occur is the intermediate value theorem, right? It's going to tell us if there is an intermediate value between two other values, okay? So based on my graph, first, since I know it's continuous, that means I can apply the intermediate value theorem. So I'm going to see if I can go ahead and figure out what the intermediate value theorem tells me. So I'm going to say using the intermediate value theorem, right? And we'll write this out. So intermediate value theorem. And I'm going to say in parentheses, as g of x is continuous, right? So we were told that in the problem. So because g of x is continuous, I'll go ahead and use the intermediate value theorem. And we'll go ahead and say we know that g of x should equal 45 at least. And let's figure out how many times, right? So how many times in the interval 0 to 30. Okay, so this is my answer. I just got to fill in how many. Well, looking at the table, recall intermediate value theorem says I need one value that's either lower than 45, the next value would be larger than 45, or vice versa, right? But basically, I need to go either from under 45 to above 45 or above 45 to below 45, and then I could guarantee that on that region, because the graph is continuous, that I would pass by a 45, correct? So I think about the first block, right? Let's look at 0 to 5. So 0 to 5, I go from a height of 100 to a height of 40. So because it's continuous, I know I have to go through all values from 100 down to 40, which means I would have crossed 45 at some point, right? So to go 100 to 40, I have to cross 45. So in this interval, I know at least once that occurred. Maybe it occurs more, right? But remember, the intermediate value theorem can only guarantee that that happens. It doesn't know what else happens. It just says, hey, you crossed 45. I might have crossed 45 a million times, right? So to go from 100 to 40, maybe I go cross 45, and then I cross 45 again, and then I went to 40, right? I don't know, right? The intermediate value theorem doesn't tell you what all the craziness of your graph is. It just says, hey, well, at least I crossed it, right? At least I crossed it once. Maybe more than once, but I can guarantee at least once, right? That's all it does. It just says, hey, I know that it did go to 45. I don't really know how many, but I know at least once in that interval, right? So that was one, for sure. Then I look at the next piece and I say, oh, well, I went 40 to 40. Well, 40 to 40 can't guarantee anything, right? It didn't go above 45, didn't go below, right? 40 to 40, it looked like it stayed flat to me, even though maybe the graph did something else. I can't guarantee, okay? It might have, but I can't guarantee it with the intermediate value theorem, right? These would have to have changed with 45 in the middle. So that's out. 10 to 15, I go 40 to 110. Yeah, I pass 45, right? 40 up to 45 up to 110 for sure happens. That's at least another time that occurred. So I'm at 2 now. At least 2, right? At least 2 times I've done it so far. 15 to 20, I dropped from 110 down to 30. There we go. I crossed 45 again. That's at least 3 times now. 20 to 25, 30 to 10. Well, now 45 is not between 30 and 10, right? So nothing happened there. From 25 to 30, I went from a height of 10 to a height of 50. Okay, well, 45 lies between 10 and 50. Therefore, that's another crossing, right? So once here, once here, once here, and once here. At minimum, right? This is the least number of times guaranteed. So I would say, oh, at least 4 times. right? So using the intermediate value theorem, knowing that g of x is continuous, we can then say that my function g of x would be equal to 45 at least 4 times on the interval 0 to 30, based on the table, okay? Perfect. There we go. Question 10, again, using the IVT, make sure we check continuity and recall that we can only find the fewest number of times here, right? It's at least 4, but it could be more. But the IVT can't guarantee more. That's the big emphasis, right? That's why I'm saying fewest number of times. Fewest means that there's a set number, right? There's 4 times for sure, but the graph could have done more, right? You're only seeing a snapshot of a couple pieces of the graph. You don't know what the real graph did. So maybe it crossed like 100 times, but there's no way to prove that. I can only prove 4 times, and that's okay, right? Four is 4. I got some information. I only know so much based on only the y values. Okay. All right, there we go. Question 10. Wrap up there.